cover apportionment in this class because it's very useful, not only for when you're trying to figure out how many representatives a state should get in Congress, but also for us ordinary people in everyday life. Anytime you have a certain whole number of objects that you're trying to divide as evenly as possible amongst various groups. In the example that we'll be doing today, we're looking at the Wake Tech Math Department and how many instructors there are for each of the various classes. Fortunately, it's not done this way where one instructor teaches only the same class. That would be boring. We all teach several different courses every semester. But for this example, let's suppose that we have certain numbers of students wanting to take each of various math courses, and we've got a certain number of instructors available to assign to each of those classes. Let's see how many instructors we should assign to each course. For this example, I looked up the actual numbers in WebAdvisor for this semester to see how many students registered for each of these courses and how many instructors are teaching these classes combined. Most of us are teaching classes not on the list, so it looks like there are a lot of instructors. Whenever you're doing any type of apportionment, the first thing that you need to do is get the total population by adding all of your individual populations together. So I used the sum function to add up all of those, and we have 2,908 students enrolled in these 4 courses put together. Now that we know that total population, we can calculate the standard quota by dividing the total population, the total number of students, by the number of available instructors that we're trying to apportion. So our standard quota of 59.35 means that each instructor in these courses will be teaching approximately 60 people in these classes. So for this example, we're going to find Hamilton's method first. So the first step for that is to find the minimum quota by dividing each of our populations by the standard quota. You can see here with the dollar signs that I used anchoring so that I don't have to retype the standard quota. But if you're not comfortable with anchoring, you don't need to use it. You don't have that many values here that it is a huge time saver. Once we have our minimum quota, that's the minimum amount for each, then we round down. Remember, Hamilton's method says we look at our minimum quota and we round down. We just chop off the decimal. So when we do that, we have these whole numbers, but then we add them up, and that only accounts for 47 of our instructors. We have 2 more instructors that we can apportion to these courses. Hamilton's method says that what we do is we look at the decimal remainders and find the highest decimal remainders. We had 2 leftover instructors, so we find the 2 highest decimal remainders. The highest is the 0.99 here, so that gets bumped up from 6 to 7 instructors, and the next highest is the 0.52, and so the 29 gets bumped up to 30 instructors. So these are our final solutions for Hamilton's method. Quantitative Literacy, your class, should have 9 instructors. Pre-calculus algebra gets 30, Calculus 1 gets 7, and Algebra Trigonometry 1 gets 3.